Welcome to the deep dive. RC cars, they seem pretty straightforward on the surface, right?
Yeah, they look simple.
But the electrical systems powering these little rockets, that's a whole different story. It demands some serious precision.
It really does.
So the big question we're tackling today is how do you actually power these things safely and, efficiently?
Well, that's exactly the mission for this deep dive. We're going to unpack the essentials of RC car wiring.
Okay.
Everything from, the absolute basic safety rules, choosing the right batteries, the connectors,
All right.
and even getting into some, let's say, pro-level wiring tricks. The goal here isn't just to understand it academically.
Yeah.
It's about helping you level up your RC game and maybe save your gear from unfortunate accidents.
Definitely want to avoid those.
Okay.
So to really dig in, we have to start with what sounds like the most critical safety rule for high-power RC. People call it the red-hot female rule. Why is that so fundamental?
Because it's electrical safety 101, basically. You never want exposed live terminals.
Makes sense.
So the rule means your battery, the live power source, it has to have the female connector. Always. No exceptions.
Okay. And why female specifically?
Because the contacts are recessed, hidden inside a protective shroud. So if you accidentally drop a wrench or something conductive on it,
I see.
it can't bridge the contacts and cause a short circuit. The ESC, the speed controller, that gets the male connector. Its pins are only live when they're safely plugged into the female connector.
Gotcha. So it's not just some random RC hobby convention.
Not at all. Think about a wall outlet in your house. It's female, right? Shrouded.
Yeah. Okay.
Same principle. Protect the live side. A short circuit means incredibly low resistance. Ohm's law tells us current skyrockets I equals V over R.
Right. The lower R goes, the higher I gets.
Exactly. And then Joule heating kicks in power loss as heat is I squared R. So that massive current generates intense, dangerous heat.
And with lipos, that's bad news.
That's thermal runaway territory. Fires, explosions. It's catastrophic. This simple connector convention, female on the battery, it's your #1 defense against that nightmare scenario. Honestly, adhering to this probably saves more gear than any other single practice.
Wow. Okay. Safety first. Absolutely clear.
Yeah.
Now let's talk about the power source itself, the battery. This is where things get interesting because you've got, 3 main types people use?
Yeah, broadly 3 main chemistries dominate. You've got your nickel metal hydride, NiMH, then lithium polymer, LiPo, and lithium iron phosphate, LiPh.
Okay, break those down. NiMH.
NiMH is, think of it as the trusty old workhorse. Super safe, very durable, pretty cheap, and you can charge them 1,000 times or more.
Solid. What's the catch?
Well, they're not very energy dense, so heavier, bulkier for the same power compared to lithium. You get voltage sag, meaning the power drops off noticeably as they discharge, and they lose charge just sitting on the shelf, high self-discharge.
Okay, so performance hounds probably look elsewhere, like LiPo.
Exactly. LiPo is the king for performance. Amazing energy density, lighter, smaller, holds voltage much better under load, high discharge rates for that real punch.
That sounds like the winner then.
Well, here's the big but. LiPos demand respect. They have significant safety risks. They are volatile if you mistreat them, puncture them, overcharge, discharge too low. Fire or explosion is a real possibility.
Yikes.
Yeah, they need special care. Balance charging is essential, storing them at the right voltage, the whole routine. And they don't last as long, maybe 300 to 500 cycles typically.
Okay, so high performance, high maintenance, higher risk. What about life?
Life, or LiFePO4 sometimes, is kind of the safer lithium option. Its main benefit is superior safety. Much less prone to thermal runaway, very tolerant of, let's say, less than perfect charging. And they have an incredibly long cycle life, often over 2,000 charges.
So safer, lasts longer.
Downsides. Lower energy density than LiPo, not quite as much punch, and they have this really flat discharge curve, meaning it's hard to tell how much charge is left just by voltage. It stays pretty constant and then drops off suddenly at the end. So yeah, choosing is really about balancing what you prioritize. Raw power, safety, ease of use, cost.
Right, makes sense. We've got the power source sorted. How do we physically connect it? You mentioned the connectors earlier. It seems like they've evolved too.
Oh, absolutely. The connectors have had to keep up with the power demands. You had old legacy stuff like the Tamiya connector.
The white ones.
Yeah, those. High resistance, maybe good for 15 amps max. Totally useless for modern brushless systems. Then came Dean's, the T-plug. Better, maybe 50 amps, but gosh, they could be hard to pull apart sometimes.
I remember those. Okay, what's popular now?
Today, you mostly see the XT series and the EC series. XT60 is good for, say, 60 amps plus.
Yeah.
XT90 handles 90 amps easy. And there's the XT90S. The S is for anti-spark. It has little resistors built in.
Oh, to stop that snap when you plug in a high voltage pack.
Exactly. It prevents pitting the contacts over time. Then you have the EC series, EC3 around 60 amps, EC5 handles like 120 amps. They use bullet connectors inside a housing. Very secure connection. Feels really solid.
And Traxxas has their own thing too, right?
Yeah, the Traxxas ID connector. It's proprietary, but clever. It allows their chargers to automatically recognize the battery type and settings. And of course, you still see bullet connectors used directly, especially for motor to ESC connections. But even there, you apply the red hot female idea. The side that could be live first, like from a capacitor on the ESC, should ideally get the female bullet.
Got it. Power source, connectors. What about the wires themselves, the stuff carrying the current?
Right, the arteries. Wire gauge is key here. It's
Yeah.
measured in AWG, American wire gauge. Lower number, thicker wire.
Thicker wire, less resistance.
Precisely. Less resistance means less voltage drop, less heat, more efficient power delivery. Now, in RC, we specifically use high strand count silicone wire.
Why silicone?
Flexibility and heat resistance. It needs to bend easily without breaking strands, and it holds up well near hot motors or ESCs. The interesting thing for RC, though, is wire gauge selection.
How so?
Because the wire runs are usually quite short and there's often decent airflow, you can sometimes get away with a slightly thinner wire, a higher AWG number than standard electrical charts would recommend for the same current. It's a trade-off, balancing weight and flexibility against pure efficiency.
Any rules of thumb?
Generally, something like 14 AWG might be fine for, say, 25 to 40 amps. For bigger systems pulling 75 up to maybe 120 amps, you'd want thicker 10 AWG, maybe even 8 AWG for extreme setups.
Okay. And finally, putting it all together. Pro-level wiring. You said it's not just about looking neat.
Definitely not. Good wiring is about reliability, performance, even serviceability. It starts with planning. Keep wire runs as short as reasonably possible. Less wire equals less resistance, less weight.
Makes sense.
Then, careful routing. Keep wires away from moving parts, suspension, gears, drive shafts. Keep them away from heat sources like the motor can. And avoid sharp edges on the chassis that could rub through the insulation over time. Use zip ties for tidiness, sure, but don't cinch them down super tight.
Why not?
Vibration. A tight zip tie can actually wear through soft silicone insulation over hundreds of vibration cycles. Sometimes braided sheathing is a good idea for extra protection.
And mounting components, like the ESC or receiver.
Ah, yes. Good quality double-sided foam tape, often called servo tape, is your friend here. It's not just sticky, it provides crucial vibration damping. Electronics don't like being shaken violently. That tape absorbs a lot of the shocks and jolts. It really protects your gear.
So that attention to detail really pays off in the long run.
Absolutely. It's the difference between a car that runs flawlessly week after week and one that keeps having weird intermittent glitches you can never quite track down.
Okay, that's a fantastic deep dive. So let's recap. We've covered the absolute must-do safety rule, red-hot female connector on the battery.
Non-negotiable.
We looked at the battery choices, NIMH for reliability, LiBos for punch but needs care, life for safety and longevity.
Right. Picking the right tool for the job.
Then choosing the right modern connectors like XT or EC series. And the correct wire gauge, usually high-strand silicone, balancing thickness versus weight.
Yep. Lower AWG for higher current.
And finally, the art of clean, smart, and vibration-damped wiring for maximum reliability.
It all adds up to a better, safer experience.
So here's something for you, our listener, to think about. We've just talked about all these detailed engineering and safety thoughts that go into a seemingly simple RC car. How do these same kinds of principles, maybe hidden principles, show up in other complex things you use every day? Think about your phone, your computer, maybe even the car you drove today. What unseen safety standards and design choices are working behind the scenes to keep things running smoothly and, well, safely? What else is built on rules just as critical as red-hot female? Something to ponder.